All right, I'm Robert Harley, editor of the Absolute Sound magazine, and I'm here with Caelin Gabriel, founder of Shunyata Research in the Shunyata factory, and wanted to ask Caelin a few questions and talk about his history and background and some of the current products. So what did you do before you started Shunyata, and how did that prepare you for making audio products and the specialized audio products that you do?
Well, in my life prior to Shunyata Research, I worked in the networking industry with a company making high-speed internet and what was called fiber channel at the time. So high-speed fiber data transmission. I've been in that industry for decades in a variety of roles. I worked in marketing, engineering. I was a liaison between marketing and engineering because those two groups don't often get along. I worked in the education department, and we need to turn our phones off.
John Val's calling.
There you go. So I worked in a variety of roles in the networking industry. And I think I was in my late 40s, I believe, going into 50s. And as was the case during that time, many of those technology companies were going out of business. We would have a CEO, and then a year and a half later, there would be a different CEO. And the industry was downsizing. And so I was one of the particularly high-paid individuals that was quite old. And they drew the line, and I was one of the guys that had to go. So unfortunately, I was approaching the early 50s, and so getting reemployed at a very high salary was difficult. So that's when I decided I'm going to turn my avocation or my hobby into something that perhaps I could do as a business. So I had always been an audiophile going back to my early 20s. I was in the military, and when you're in the military, you were either into drugs, cameras, or audio. And so I was very much into the audio part. I was stationed in Berlin, Germany, and so we would do parties for the local population and on the base. So we had stacks of Bose 901s with monster amplifiers. We had phase linear 700s, phase linear 400, Bose 1801 amplifiers. And we'd set it up in the quad, and we'd spin a lot of records and make a lot of people happy. So that's kind of where I got started in the audiophile side. And all through my career in computing and networking industry, I was always interested in audio as a hobby. And like so many of us, I had spent tens of thousands to nearly $100,000 on an audio system. And I actually was quite frustrated at trying to improve the system to get it to sound more like real music or live music. I always attended concerts and orchestras, and the electronics always had a certain signature that removed you from that live event. So I used a lot of the equipment that I used in the network industry. I had access to some spectrum analyzers and data analyzers. And so I was trying to determine, well, why is it that it has this overriding, quote, electronic sound, this noise signature, and this harshness on the leading edge of transients? So this was out of curiosity for myself. And so I did a lot of research while still working in the networking industry. And I discovered a few things related to power conditioning and also the effects of power supplies and rectifiers and transformers. And so what I identified, I wasn't looking specifically for something related to power. I was just trying to see, well, what are the things that are causing this? And so I settled on that much of it had to do with the power supply itself and the power feeding the power supplies. So when I was let go in the networking industry and it was very difficult to get an equivalent position, I decided, well, I'm just going to go ahead and produce a product related to what I had found. And so the first product that I produced is what I showed you in the other room, which was the original power conditioner. It was not called a Hydra. That was later. That was the marketing name we came up with. But as you saw, the box is wooden, and it had conventional looking outlets. But what I was using in that was the predecessor to our patents that had to do with ferroelectric substances that actually absorb noise of radiated electromagnetic fields. But instead of doing it through the magnetic field, which is how ferrites work, ferroelectric substances, which are primarily crystalline substances, you can tap into the electromagnetic field through specifically the electric field. And so the original power conditioner was based on that concept. So it didn't have any coils or transformers or capacitors in it. It was absorbing noise purely through that substance. And so it had a particularly nice dynamic. It didn't compress dynamics like power conditioners of the time. So pretty much that's how I got started. And so I made the products primarily for myself, but I had a really good dealer who was a friend in Washington State. And I was telling him about it, and he said, well, why don't you bring one of those over and let me try it? And so I brought the prototype over and let him listen to it. And he said, this is really good, but what's really hot right now? And remember, this was about 1997, 98. And he said, what's interesting right now is power cords. And believe it or not, power cords actually make a difference. I said, you're kidding, just a power cord? And he said, yeah. And I was telling him about the ferroelectric substance and how I had a patent on it. And he said, you know what? Would it be possible to put that in a power cord? And I thought about it for a minute, and I said, oh, no, man, that would be really hard. Because you would have to try to put it in tubes, and then you would have to try to have a conductor in the middle of that. And then first of all, it'd be heavy. And then second of all, if you tried to bend the cord, it would be very difficult because it would be the equivalent of compressed sand, that it would be very difficult to move it. So I said, no, I don't think so. But as time went on, I thought about it, and I found some substances that were actually crystalline in nature and very lightweight, and they actually were smooth, which allowed them to move freely amongst themselves so it wouldn't lock up. So our first products were actually power cords that had the ferroelectric substance built into them. And so this dealer friend, he had many VIP customers, and he let some of them try them, and they caught on. And I was building them on my countertop at home with my wife. She took the orders, I built the products, and that's pretty much how we got started. And then as we moved along, I needed to make more of them than I could make, and so I actually brought my mother in, and she helped me make the cables. And so we really, truly started as a family business on a kitchen countertop.
And now how many square feet is your factory, and how many employees do you have?
Our factory right now is over 20,000 square feet, and I'm not sure, how many, 25, 30?
32.
30,
32 to 35.
See, you can tell I'm not. You can tell I'm not really connected to that. All of the original employees, we have. I'm very proud that all of the original employees, which includes Chris, which is our production manager, and Grant, I hired them probably in 1999, within 6 months of each other. It was over 20 years ago, and they're still with me. And Richard, we rescued him from selling cars at a Toyota dealership. He's been with us over 18 years. So all of our original people are still with us, and we just keep adding more people as we expand and as the products become more popular. And one of our most recent additions is Alina, who's our fantastic social media manager. And so we're very happy to have her as our recent addition.
So you've taken a very different approach to power conditioning and power cords, in that you want to be able to objectively measure the performance differences. Can you talk a little bit about that and why you've taken that approach and why that's important?
Well,
because there's a lot of mysticism in
Yes.
power cords, and people talk about quantum tunneling and things like that, but
Right.
you're more of a hard-nosed,
Right.
data-driven engineer.
Right. Okay. Well, I would say that the first power cords that I built had nothing to do with measurements. It was purely the empirical method of getting different materials and doing the test that is the end result, which in an audio system is, well, what does it sound like? So those were the first initial tests. So I'm a person that wants to really understand things and how something works. So I had to build a knowledge base. And for me, I would read what other designers had done and what other people thought was why something worked. But even though I could accept what people were saying, I never take it at face value. I always have to verify it for myself with my own tests. So I found that there were a lot of misconceptions of the day, and I found that many of them were wrong. I verified that some of them were correct. And so I built many, many prototypes using different types of metals for the conductors, many different types of dielectrics, that would be the insulation on the wire. And I found that the different metals had different sound qualities, and that the different dielectrics had different characteristics that weren't necessarily like a tonal quality, but the dielectrics did something that had to do with what almost sounded like distortion or noise components. And then, of course, you've got connectors, and all the different connectors had a different quality. So what I've found in doing all these tests, and this is before making a product, is that almost everything made a difference sonically. So you could build a product based on just testing, kind of like a cook. So if you give a great chef a bunch of ingredients, quality ingredients, and you ask them to make a soup or a stew, they'll take certain foods and spices and put them together to achieve what they want to do. And so I found you could do a similar thing with the power cords, is if someone said, well, I think the system sounds a little bloated in the bass, if you knew what each one of those components did, you could shift that impression. Or someone said, the purity's not quite there. If you've done enough tests, you would know what the causation of that would be. So the first products were built that way. So I would say it's more like a audio cook. And you find many products that are built this way, purely subjectively. But being the engineer that I was, it bothered me that here's something that, objectively speaking, quote, shouldn't matter. It's just a wire with just insulation, doesn't have transistors, doesn't have coils, doesn't have capacitors. So how and why do these different parts sound so different? So early on, I set about using various test equipment to try to determine, can we measure this? Is it possible to measure it? And as many people from that time will tell you, many of them skeptics, and they had valid points. They said, well, if you measure, quote, the frequency response of the cable or the resistance of the wire, or the inductance of the cable, you would find that it's not different, but different things would sound different. So most audiophiles know that if you have a silver cable and you have a copper cable, they sound different. Mm-hmm. You can objectively measure them and find that they're very similar within tenths of a dB of one another, within the range of just production variation. So it pretty much frustrated me that it was difficult to measure, but I persisted. That's one of my characteristics, is I don't give up. So eventually what I discovered is that one of the primary reasons power chords sounded differently had to do with their current transfer function. And that can't be measured with steady state equipment, or frequency response, or harmonic distortion, or total distortion, as you would measure something like an amplifier or a preamplifier. So as is the case, and you'll see this through the years, that we've actually had to build our own test equipment. And so one of the first things I built is what we called the DTCD analyzer. That was Dynamic Transfer Current Delivery Analyzer. So what this device did was simulate the power grid. So I'm just going to back up and explain how someone like yourself, Robert, would test a cable. You would take a signal generator and you feed a signal into one end, and you could connect it to an oscilloscope or a spectrum analyzer or dB meter, and you can measure what comes out the other end. So this is pretty much what I would call a signal transfer analysis measurement. But that is not how power chords work. Power chords, when you plug them into the wall, you're not transmitting a signal. You're connecting it to a current source that is alternating. It's rising and falling. And when the power supply of the component pulls current, that current exists on the power grid. So when you plug it in the outlet, there's a potential there. And when the power supply in the component turns on, it switches and allows the current to flow. So in a sense, it's drawing, it's not sending. And this is a different function that needs to be measured in a different way.
It's not a steady state thing like a fan or a light bulb. It's impulses at the peaks, the bottom and top of the sine wave in short bursts.
Yeah, thank you for that. So basically, in a 60 cycle power system, the positive portion of the wave and negative portion consumes about 8.33 milliseconds. So during that short period of time, the rectifier only turns on for 10 to 20% at the crest of that wave. And so when the power supply turns on, it pulls on the line very hard, and there's an instantaneous inrush of current. And so the equivalent amount of current that flows during that short period of time can be hundreds of amps. So it could be 100, 200, 300 amps. Now, that doesn't mean it's pulling that continuously across the whole wave. It's just for that short period of time. So once you understand that, you start to understand that junctions within a wire or a power cord and also the inductance of the cord become much more important than you would think. People of the day would often say, well, power cords, it's a very low frequency because it's only, they'll say it's transmitting, which is false, transmitting 50 hertz or 60 hertz. But actually, the current transfer function is a high frequency, high impulse, high current event. And so the DTCD analyzer simulates the power grid so it has a very high voltage with an extremely high ability to deliver current in a pulse. And then we built the analysis circuitry such that when we pulsed it, we could get a very precise reading of how much current was being drawn during that first 50 milliseconds. And what we found is we finally found the holy grail of can you actually measure the difference between power cords, and we found that there was as much as 40 to 70% difference in the ability of one power cord to the next in its ability to pull current during that very short period of time. So that was just one of the first in discoveries that we had made to objectify these measurements.
I thought that was a really important development in understanding power systems for audio.
Yeah, well, it did a second thing for us. It wasn't just that we had proved that we can objectively show that there's differences between power cords. It gave us a competitive advantage in the development of our next generations, because we found we could apply this measurement to the wires that we developed, the connectors that we developed, the process and procedures we use to connect a connector or a junction to a wire. We found that the soldering materials, the clamping methods could dramatically affect the DTCD measurement. So those gave us the ability to objectively measure connectors and the wires and the junctions to improve the performance of the cable objectively.
Hello, ladies and gentlemen. I'm Tom Martin, executive publisher of The Absolute Sound and a reviewer here on the TAS YouTube channel. I'd like to make you aware of an offer to get our weekly newsletter simply by providing your email address through the link that's on screen right now, or there's a link in the show notes below. Twice a week, we will send you written audio reviews, music reviews, news of new audio gear, and our 3 times a year Editor's Choice, Product of the Year, and Golden Ear Awards, so that you can find the best audio equipment that's currently on the market. It's easy to sign up, and we hope you'll join us. Now back to the show.
Another idea you pioneered that I think really advanced power conditioning was the idea of component-to-component noise. It used to be power conditioners were thought of as like a brick wall to keep noise from the outside in, but you took that idea further and talked about the need to isolate components from each other because all the components are connected to each other through the AC power system. So if you have noise like from a microprocessor in a DAC, it can get into the preamp. So can you talk about how you came on that idea and what technology you developed to address that?
I actually think you explained that very well, probably better than I could have done. So at the time, the design belief or the philosophical belief for a power conditioner was that there's something bad outside of the home, and specifically outside of the system on the power grid itself, i.e. noise or EMI or RF components, and that we want to keep those away from our very delicate equipment. So if you had a phono preamplifier, it could be very susceptible to noise in the environment. So the thought is how do we build a power conditioner that's essentially a low-pass filter? So we want to filter out radio frequencies, high-frequency components, impulses, like impulse noise, switching noise, like when the refrigerator would switch on, or someone would turn the printer on, and you'd hear the pop through your system.
All that junk on the power line.
Yeah, and it's particularly annoying for an audiophile when the wife or someone turns something on and you get this big pop through your system, and you might have a horn system, and you feel like the speaker is going to jump right out of its enclosure. So that was the thought, is that how do we want to be able to get the current, the 50 hertz or 60 hertz current, but we want to also limit the interference. And actually, technically, that's pretty difficult to do without impeding current flow. Now, remember what we said about DTCD, that our research had shown that the way power supplies pull current is not like a fan or a light bulb. It doesn't pull it over the full sine wave. That only pulls it as pulses at the peak and the trough of the AC sine wave. So actually, it's high frequency, and it's an impulse and high current. So traditionally, power conditioners were built with very large coils and transformers, and the very nature of an inductor is to resist a change in current. So that's antithetical to what I just said is important from a DTCD point of view. You want very fast current transfer, but the very nature of those type of designs inhibits the transfer of current during that critical portion. And this is the reason that so many people that had experience with them said, I'm not going to use a power conditioner in my
It quashes
system.
the dynamics.
It destroys the dynamics.
That was the knock against power conditioners.
Right, especially in an amplifier, because amplifiers pull very large gulps of current from the power line. And so if you have a device in front of them that's inhibiting that, naturally it's going to lack in dynamics and power. So I think that was a major thing in the design of our power conditioners from the very beginning. Our cardinal rule was don't inhibit instantaneous current draw. And that necessarily meant in the design that you can't use coils, you can't use transformers, you can't use ferrites. So anything that would inhibit instantaneous current was a no. And what we found is that even without any objective filtering, a power conditioner that had exceptional instantaneous current flow sounded better than a conventional one, or just connecting to the wall. And furthermore, they sounded quieter. So the perception was that the noise floor dropped, when actuality, you understand this very well, Robert, that the macro and the micro dynamic range that we perceive is a difference between the noise floor and the peak. And it's those transient peaks that give us the sense of dynamics, like fast and a hit on the tom-tom or a saxophone.
Sense of life to the music.
A sense of life. And when you gain that sense of dynamics, the perceptual effect is that you've lowered the noise floor. But in actuality, measurement-wise, you've not lowered the noise floor. You've improved the dynamic range, which gives the perception of a lower noise floor. So the first hydras had no filtering in them, other than the ferroelectric substance, which works primarily at very high frequencies in the megahertz to gigahertz range.
You've just launched an entirely new product category in the ALTAIRA grounding system. So can you talk a little bit about what led to the idea to make a grounding system, and and how long you'd been thinking about it and how it's implemented in this new hardware.
Okay. So I want to set the record straight. I didn't come up with it. It's obvious there's many grounding products on the market, and I like to give credit where credit is due. And I think there's one company that really popularized in an almost cult-like fashion the concept of using grounding in an audio system, and that's Intrique. I'm not sure how it's pronounced, Intrique, but they make beautiful artisan-type products, wooden boxes, and they have some type of material in the boxes that seems to take noise away from the ground. So all credit to them. I think they popularized it. They have an almost cult-like following. And then several other companies have come along that are more commercial, that have made grounding products. And I think most of them have done pretty well. So I had customers and dealers and distributors who were saying, and this was 10 years ago when they were telling me this, you need to make a grounding product. And I said, well, why do I want to make a grounding product when there's people out there that are already making them? They seem to be doing a good job. I don't really want to make a product to have a product in a category. If we have something to offer where it's truly superior, then I'll make it. So I resisted it actually for years. And then about 4 years ago, and more people were making grounding products. Excuse me. And so I said, okay, well, I told my director of marketing that I'll tell you what I don't like about grounding products. They're tweaky and they're not consistent. You read the forums and some guy will say, well, I have Constellation gear and I hooked it up and it didn't do a thing. Another guy will hook it up and he's got Prima Luna and he goes, oh my God, the earth, sun in the sky opened up. So I was frustrated by that it seemed to be very much a tweaked product, wasn't consistent, and it seemed to me there was no objective science behind it at all. Even the people that were making the devices didn't seem to have good, coherent explanations for A, why it would work, and B, why their product would be superior to simply running a ground braid and grounding everything together. I came from the networking industry and the telecom industry where grounding is common, is mandatory. You have raised floors with huge ground braids, and all that equipment is individually grounded primarily for safety reasons, but secondarily it drains noise from those switching systems. Unfortunately, I mean, in the old days, back in the 50s and 60s, almost all equipment had a ground screw or a ground lug. And as we've moved along through the 70s and through the 80s into the 90s, there's components that are mass market, plastic chassis, but unfortunately, even high-end components that are made with metal chassis and even tube equipment, they've stopped putting the grounding posts on there. And I think primarily because people didn't really go to the trouble of grounding the equipment. And I think many people miss the point that just doing star grounding with simple wire and braid has a potentially very beneficial effect to the system. So sometimes people will say, well, why should we buy your grounding product? And we'll say, well, you probably shouldn't if you're not even doing basic grounding. You should do that first because that's almost free and you're going to get a very significant performance benefit. And if people will take the time to actually do that, then they will understand that grounding is important And it's very much now in our modern times forgotten or overlooked.
So it drains noise from the chassis and the signal grounds and puts it through a filtering system and then goes to an earth ground. Is that the basic?
Oh, if you're talking
premise?
about the ALTAIRA,
The ALTAIRA.
specifically, I think we just need to back up and say, well, why does grounding work at all? What does it do objectively? And there's two things. Number one, that people don't understand is that you can take a voltmeter and you can measure the voltage on a chassis of a specific component, and you may find, compared to an earth ground, there may actually be a voltage on that chassis. And you would think there isn't one, but there may be several millivolts, and this is the result technically of leakage currents or induced currents from large transformers. So you can actually have both DC and AC voltages on chassis. Now the interesting part is that you can have a voltage on one chassis and a different chassis in the same system can have a different voltage. Now when you connect those two together with an interconnect, the interconnect has a ground wire, and so it's connecting the chassis ground of one component to the chassis ground of another component, and you now get, because you have a voltage difference, you now get currents through that interconnect.
Ground loop.
A ground loop, what we call a ground loop. So it could be a DC current, which is bad, but very common it's an AC low frequency component if it's coming from the transformers or the power supply, and we hear this as hum. But there's a second, more pernicious form, which is high frequency. You do not hear it as a hum. And so when you hook it up, you don't go, oh, damn, I've got a ground loop, because you don't hear anything. But what happens is you're modulating the ground planes of both power supplies, and that modulates the signal, because in the amplification circuit, you have an internal amplifier, and it amplifies in reference to the signal ground. And so if the signal ground is moving relative,
the whole audio signal is moving
right,
along with it.
right. And this is one of the other misconceptions that many audiophiles have, is they'll say, oh, I don't have noise in my system. And they will say, I have my system on and the volume's at the normal listening level, and I'm not playing anything, and I put my ear up to the speaker and I don't hear anything. I don't have noise. I said, well, that's not true. You don't have noise when you're not running a signal through there. But as soon as you run an amplified signal through there, the noise is not sitting down here somewhere. It's not in space. Noise doesn't sit down here and then I've got my signal up here all pure and pristine. And if the signal gets low enough down here, I will hear it. That's not how it works. The noise actually rides the signal.
It's part of the signal. It's embedded in it. Yeah,
it's integrated.
It's not a separate thing that sits there.
That's absolutely right. And so that's a concept I would really like people to understand better. So whether it's better power supplies or better filtering in the power supply or better power conditioning where you reduce some of that noise, there's also the other side of it, which is in the grounding side, is noise exists in the grounds, and we can tap into and absorb that noise. And so you can think of it as a parasitic way of removing noise, even though it's technically not a filter, as you would think of it like a signal where I'm passing it through an inductor and a capacitor. There is no signal transfer with grounds. Supposedly there shouldn't be current flow through there, but the noise exists on the chassis and the ground wires. So the way, I think you asked how the ALTAIRA functions, the ALTAIRA is a little different than other grounding products in that each one, there's 6 terminals on the back, and each one of those terminals is individually pulling noise from the component that it's connected to. So it's not just like a big vat or a tank where you're running ground wires to it and that big vat is absorbing noise, actually each one of those connections is individually removing noise from that specific component. And so when you multiply that over multiple components, this component generates noise and the ALTAIRA is reducing it. The DAC has noise in the chassis and it's removing it on this channel. So the cumulative effect is additive. And so the ALTAIRA is exceptional in that regard. And secondarily, we actually make two versions of an ALTAIRA. One is specifically designed to remove chassis ground noise, and the second one is designed to remove signal ground noise. And it's very important that those two be treated differently. So to go back to my original thoughts on why I didn't want to do a grounding system was because they were tweaky and you get variable results. What I found in my research is the reason is that people did not understand well the difference between chassis and earth ground and signal ground. And that certain equipment you could chassis ground effectively, but other equipment you necessarily need to signal ground it. And it was the mixing of the two that caused the variable result. And so that's why in the ALTAIRA, there are actually two models. And if you follow our user guide and our grounding concepts, we explain very clearly how to determine which method you need to use for each component.
Yeah, the literature is very informative and explanatory.
Great. Thank you.
All right. Well, it was great talking to you.
Thank you, Robert.
Thanks.
Thank you.